So today I wanted to do something kind of different and talk about a tool called Octave that I've been using as part of my machine learning labs that I'm taking. And it's a pretty cool tool. It's kind of like a glorified, graphing and programming calculator. And I'm still learning this, so there's probably going to be more videos as I learn more. But the basics that I'm going to just kind of demonstrate today are pretty neat. Just if you want to do like basic arithmetic operations, 3 plus 3, 3 divided by 3, um, you know 4 to the 13th power or something, basic arithmetic operations. What is 2 times pi, things like that. Very basic, out of the box. And you can define variables, so I can say pi squared equals pi times pi, right? Or I can say pi squared equals, pi to the second power, or whatever. So very cool stuff, very easy. There's a function called who that basically allows you to see things that you've defined. You can use the display function to look at the value of things if you want. You can also, there is a sprintf function, which works very much like you would expect in C. So the value of pi squared is 0.2% to pi squared. All right. Oops, sorry. Pi squared. There we go. So those things all kind of work very much as you expect. So, but and if Octave could just do that, then it wouldn't be a very interesting program because there's a lot of things that do that. No, where things like Octave get really, fun and exciting is when you start defining things like matrices. So we all know what matrices are. Just, values that are put into rows and columns. So very basic matrix, 1, 2, 3, and 4, right? If I look at that, that's basically what my matrix looks like. And you can do, really easy things like you can define, B as, 3 times A, right? Which if I look at it, it basically multiplied each of the indexes, by 3, right? And I can even multiply matrices themselves. So I can say, C equals, A times B, and, we can trust that that's actually what the value is. There are certain things that, there are functions that are built in that'll tell us, like how big is the matrix. So A is a 2 by 2 matrix. And there's also a thing called length, which basically will give us the longest dimension. So I might want to define a vector, right? So v equals like 1, 2, 3, 4, say for example, right? So length of v is going to be 4. If I defined v to instead be columns, right? If I do length of v, I'm still going to get 4. But if I do size of v, I'm going to get, this is a 4 row, with 1 column, right? Which is, versus when I defined it this way and I do size of v, right? Now it's a 1 by 4. So you can kind of do all kinds of, cool matrix kind of things. And technically, you can define, matrices that are, multiple dimensions. So, we did, columns and rows. But if you need to, you could do a 3-dimensional matrix if you want. I'm not necessarily going to go into that right now, but there's some other cool stuff too. Like there's a function called ones, which I believe if I put in a value will give me a matrix that's just full of ones, to any size I want. So I can have a matrix that's all ones of a certain size. I can do similarly, there's one that's all zeros. And technically, you can make a matrix that has any number in it because you can just multiply, 7 times 1s and you get a matrix of 1s. There's also a function called I, which gives you the identity matrix. So as we all remember, the identity matrix is a matrix that when you multiply it, it's a matrix that when you multiply it, basically times another matrix, you get the matrix back itself. So use I psi. Oh yeah. Okay, I get it, right? Because I didn't finish that. Yep, there we go. Okay, so if I do A times I. Yeah, that's right. Because it doesn't. Because I doesn't take a matrix as an argument. It takes a number. Sorry. There we go. So if we multiply A times the identity matrix for the size of A, we get basically A back. So, really, cool stuff. You can even actually do even crazier stuff like raise matrices to powers, which, of course, just multiplying it by itself. You can even, do crazy stuff like that, divide matrices, all kinds of stuff. So all the kind of, basic matrix stuff that we all had to do by hand when we were learning linear algebra, you can just go in here and do it yourself, which is, really cool. So a little bit about syntax. Obviously, if you're going to create a matrix, you start with a square brace, and then basically for the rows, you basically you can split out the values by spaces, or you can split them out by commas. That works too. And then when you want to split out rows, you put a semicolon. So if I do, 2, 4, 6, 8, 10, and 12, close it out, right? I get essentially the same thing as if I hadn't put in commas at all, right? Same kind of thing. So you can put the commas in, or you don't have to put the commas in. Either way, it works. But that's pretty much the basics of where I've gotten so far. I'm still learning, but it's a pretty cool tool, as you can see. And there's help. You can actually also read the documentation directly in this Octave tool. And as you can see, there is a lot of stuff in here. The last thing I kind of want to show, back to the command window. So say I want to, let's see, what did I, graph equals, let's see, -6 times the square root of 10 times rand and 10,123, right? I think that was, all right, which gives us all these values. And then basically what we can do is draw a histogram of this. We get a little histogram. And the other cool thing about this is that we can kind of say how many things we want, in our histogram. So there we go. We have 50 samples versus, at the default, which or I can have, 1,000 samples, whatever. So, I can just kind of graph the data in that, and then, get a nice pretty graph, and I can move it around on its axes, and I can turn the axes off, turn a grid on, I can have an auto scale, all that kind of fun stuff. So you can put all this data into matrices and then do graphs on it and kind of cool stuff. And obviously one of the big things I'm going to be doing with this is graphing the cost functions and things like that, and showing how we're achieving finding the optimal machine learning coefficients, so that we arrive at a algorithm for finding doing predictions. Anyway, this is a really cool tool, and I'm just getting started, and it's pretty awesome. So and it's totally free, so you can just go to, where did I get this from? Da, da, da. It's from, FTP, GNU.org, GNU, Octave, and I did the Windows version, but they do support Mac OS, BSD, Windows, and there's other different ways of installing it. So you can get it from Homebrew if you're on the Mac, or Fink. There's free, even BSD. Does anybody still use FreeBSD? Drop me a note. Let me know if you're still using it. Linux, of course, which actually comes as part of if you want to yum install it and things like that. So lots of different ways of getting this. So if you have questions, let me know. All right. Thank you very much.